Okay. We're ready to move on to a more formal discussion of cardinality. Cardinality, the cardinality of a set is just the number of elements in the set. And so the first thing that you can think of, really kind of the first impression that you get is either there's finite sets or infinite sets, and all finite sets are more or less the same. And then all infinite sets are more or less the same. And that's a reasonable assumption that just turns out to be wrong. And so I want to explain this. And so what we're going to do is I want to start by explaining that infinity is super weird. And I want to start actually with what's called, so I want to start by just a quick discussion of what's called Hilbert's hotel. David Hilbert was a very prominent, very famous, rightfully famous mathematician, probably the most famous mathematician in the 20th century, or one of them, and just absolutely a super important mathematician. And he devised a thought experiment, which now bears his name. It's called Hilbert's Hotel. And the idea is just to prove that infinity doesn't play by the same rules as any other number. Infinity, after all, is not a number, so that seems okay. But we just want to emphasize how strange this is. And so what you do in Hilbert's Hotel is let's say you have a hotel and there's infinitely many rooms. And let's just make it easy for my drawing ability here that they're all in a row. So you have rooms 1, 2, 3, and so on. So 1, 2, 3, 4, and so on. Okay. And then what happens is you can laugh to yourself about my hotel worker here. And there's a person working the front desk at the hotel. This is the front desk. Sure, draw it however you want. And someone comes up and they say, I want a room. I want a room at Hilbert's Hotel. And the person at the front desk says, sorry, we're completely full. And so we're just going to assume that there's a person in each room is taken. Okay, so there's a person in each room. And the person that goes up to the staff of the hotel says, well, you can still make room for me. And the staff member said, no, you don't understand, we're full. And the guy who wants the room says, well, you can still make room for me, just have everyone move down a room. And if you were to do that, if everyone moves down a room, what happens is, if everyone moves down a room, now room 1 is open. And so if everyone moves down a room, now you've made room for me, and we can go there. That's perfect. So it turns out that there's still a room, even if in a infinite hotel all the rooms are taken, there's still room for an occupant, and that's fine. And he said, okay. And so now, again, all the rooms are taken, and now 10 people come. So now there's 10 people. These are all supposed to be people, 7, 9, 10. So now there's 10 people that go up and they say, hey, I want to have a room. And the staff member says, sorry, we're all full. And they say, well, why don't you just have everyone move down 10 rooms? And if you do that, then there's room for us. And since there's infinitely many rooms, you're never going to run out of rooms to send people to. Everything is fine. And so it turns out, even if there's 10 people that come up and want a room, you can still make room for everyone at the hotel. And so they do that. These 10 people get a room, and we move on. And then a bus filled with infinitely many people show up to Hilbert's Hotel. And they say, we all want a room. And the staff at the front desk says, well, we're full. But the people on the bus say, well, you can still make room for us. And so the puzzle I want to leave you for now is, how can you make room for infinitely many people? As a hint, you can't have them move down infinitely many rooms, because that's not a well-defined operation. Okay, so you can't have them move down infinitely many rooms.